So hi everyone. Today we'll try to understand how the most ultimate chatbot that has been the talk of the town recently, ChatGPT works. We'll try to understand the machine learning algorithms running behind it, how it is trained, and all the technical parts. So if you have been active on social media, you must have heard of ChatGPT in the recent months. So eventually, it is a chatbot which is able to answer almost all sorts of queries, be it your life problems, be it some technical issues, or anything else. How is it trained? How is it able to do this? So let's find out. So before jumping on to understanding what is ChatGPT, how it is working, we need to first of all understand the basic concept called as transformers. So you must have heard of the paper that came in some way back in 2016 or 17, I guess, that was attention is all you need, which discussed about the breakthrough models of transformers and the concept of attention in NLP. So if you haven't, I would suggest you to watch one of my previous videos on attention is all you need. I have in detail I have explained what is attention and how what is a particular structure of a transformer. So taking up the important notes from that particular video, a transformer consists of two major parts. One is an encoder and other is a decoder. Now the encoder part got evolved to form BERT. Again, a very important algorithm, very important model that you must have definitely heard if you are in the data science space. And the decoder part got evolved to GPT, generative pre-trained transformers. So now you must have guessed why we started with transformers, because from transformers we got GPT, and from GPT we got chat GPT. So basically GPT is nothing but the decoder part of the transformer. So if you go through that video, you go through my previous blog on transformer, you will get it. What is the structure for GPT? So a big question before jumping further on ChatGPT: why do we need so many models? Say Transformers, Bird GPT coming in. Why can't we use a single model for everything? Like why it was not Chat Bert or Chat Transformers? Why GPT was used? So if you read here, Transformers are general architecture for processing any sort of sequential data. Now it can be time series as well, because it is also sequential. While BERT and GPT are pre-trained model basically for NLP purposes. Now, even in these two models, BERT is not majorly used for problems that involve generating text, right? So GPT is particularly useful for tasks that require generating content and natural language, and hence ChatGPT uses GPT for generating responses to our queries. ChatGPT uses a variant of GPT-3 which has zero-shot learning capabilities. Now, what is zero-shot? So basically, zero-shot learning also I've covered in my previous videos. So I will give a brief here as well. So in case of zero-shot learning, it is a method of machine learning where the models are trained in such a way that they are able to perform tasks for which they are not even trained. For example, if I give you an example, it can be the case that you are training your model to classify dogs and cats, and eventually if a image for fish comes in, then also the model is able to recognize it as fish. This is called as zero shot learning. Zero shot means that we haven't shared it the information about what data it can see in the future in the production, but still it is able to work it out and it is able to correctly classify. So in terms of classification is one of the examples, but zero shot basically means that one can train models to perform tasks for which it is not prepared. So even chat gpt has zero shot learning capabilities, and that is why whenever you're asking it a random question like write a code snippet for me, give me life advice on some particular problem, prepare an itinerary for my next trip, ChatGPT is able to do that, because though it is not prepared, though it is not trained for such task, it is still able to do it because it has zero shot capabilities. So right now, we have just started the blog, and we have got two important information about ChatGPT. One is that it uses GPT architecture, which is basically a decoder architecture coming from transformers and has zero shot capabilities. The next part is a bit tricky one, a bit difficult one. We will be discussing about how ChatGPT is trained. So the training part of a ChatGPT, as you can see in this exam, this particular flow diagram, it's quite complicated. We'll try to dissect it into simpler elements. So the training of ChatGPT involves three major components: pre-training, supervised fine-tuning. Pre-training is this part, a safety model is this part, and finally a reinforcement learning with human feedback, that is called as RLHF. This is quite a buzzword now. Recently it has come up. So the training part consists of these three things. So so let's go one by one. Pre-training. So first of all, let's understand what do you mean by pre-training. So in pre-training, a model is trained on a very large corpus. for some very general task, so that later on it can be tweaked on to perform specific tasks. For example, in pre-training can be considered as training the model for some general tasks, so that eventually when you're training it for specific problems, like I said, for the three problems that I mentioned, it converges faster, and second thing, it requires lesser data. Right. Why so? Because when you have trained it on a similar data set, it's not for the exact problem. You have trained it on a similar data set, so the weights are not getting initialized from zero. Right. So when you have trained it on some previous general tasks, the weights have been initialized and they are in a rough state now. Like they would be assume it to be 70%, 80% correct. Now, when you're fine tuning it to some specific task, these weights are just need to be tweaked little bit, and not to find the convergence from zero. That is why pre-training is done for complex problems where the data set can be less, or like we need to perform multiple tasks, and training again and again from scratch is costly. In that cases, pre-training can be taken. Like here you can read about this example. So ChatGPT uses a pre-trained GPT-3 model, which is trained on humongous corpus taken from the internet. It's quite fine. Now moving on to fine tuning. So fine tuning, as I already told you, when you're trying to retrain a pre-trained model for some specific task, that is called as fine tuning. Fine tuning can be of two types basically. One is supervised fine tuning, where for the specific task we have the labeled data set, and hence we are training the pre-trained model using the labeled dataset, and other is a unsupervised fine tuning where we don't have the labeled dataset. So in case of chat gpt training, we have the labeled dataset, hence it is trained using sft, supervised fine tuning, or conversational dataset. So this conversational dataset is nothing but uh, conversations that are generated by humans, and then this pre-trained GPT-3 model is trained over that generated data set. So now I think till now we are quite clear that first of all we have a pre-trained GPT-3 model that is trained over a corpus from internet. Second thing, we train the model using SFT over conversational data set. Now, the third part that is a quite interesting part and the most complex part comes in is the reinforcement learning with human feedback. That is a further fine tuning the model. So why it is required? So as it is mentioned in different places, is that key after SFT, that is supervised fine tuning, there comes a problem called as distributional shift. So let me explain that. It's quite easy. So assume that, as I told you that for SFT, conversation samples are generated by humans. Now even if you are generating thousands and 1 lakh of samples, you won't be able to cover the whole universe, right? So if you have used ChatGPT, you would have understood that it has the knowledge from every domain. How it is getting that knowledge? Because you can't prepare such a conversational data which covers each and every domain, each and every talking style as well, right? So it might be the case that the data set that has been prepared might represent a very small fraction of all the conversations that are possible, right? So this is called as a distributional shift. So to generalize chat gpt for all styles of conversations, different domains, is a tough challenge. That is why the authors came up with an idea of reinforcement learning with human feedback. Let's understand this is the most important part of this whole training process. So first of all, we need to understand what is the reward model and how it is prepared. So reward model is basically intakes a response generated by the SFT model after training to supervised fine tuning. We get the SFT model and gives us a score for that response. How good the response was, how humanly the response was. So how such a model is trained? So after SFT training is done, a human agent chats with ChatGPT. So if you know that generative model, as ChatGPT is a generative model, for a given input it can generate multiple output because of there is a stochastic nature present in generative models. You can prefer to my previous blog on generative modeling to understand what are the different features of a generative model. So if you read that, you will come to know that generative model have a element of stochasticity, that is an element of randomness. So if you input a particular input, some input x at timestamp t, and then at timestamp t plus 1, the outputs can differ a lot, right? So in this case, once a human agent chats with chat, it gives it a prompt, and he tries to generate multiple outputs out of it, and then some other human agents tries to rank these outputs, how good these outputs are in terms of how these responses are mimicking human conversations, right? Now once this data gets labeled by the other agent, now we take the prompt, and one response at a time. We form a pair, and eventually we train the model for that score. So we input the prompt alongside the response, and the output becomes our the particular rank that the human agent has provided. So it's again a supervised learning method only, because we are labeling the data set and then we are eventually training a model to generate rewards for the given response given by ChatGPT. Now we have understood what is the reward model. Now, using the SFT model that we have prepared earlier, alongside this reward model, we will get to our final model, that is ChatGPT, by using an algorithm called as proximal policy optimization from reinforcement learning. It is quite interesting. I won't be explaining the whole of it, because it is more of an advancement over advantage actor critique method that I've already discussed in detail in my previous algorithm. So you need to refer to that, because it is a very lengthy, a bit difficult concept, and it would require some sort of an explanation at length, which I would wish to avoid in this particular video, because I've already covered that. So, do read about A to C algorithm before jumping on to understanding proximal policy optimization. So, I'm assuming that once you read that, you will come to know that A to C has a loss function minus 1 into summation of log probabilities into AT. So, AT is the advantage term that we get, and log probability is basically the probability of the action that has been taken. Right. Now here you can see the advantage term as well, reward plus gamma into value function for future state minus value function for the current state. Now value function that we're getting is from the value network, that is the critique network, and the reward that we are getting and the log probability that I have mentioned in this particular formula, probability for the action we are getting from the actor network. So advantage actor to critique involves two networks, actor and critique. You just go through that video or through that blog for a better understanding. Now, in case of proximal policy optimization, what we are doing is that we are changing this particular loss function. So instead of using this particular loss function minus 1 into summation log probability into AT, what we are doing that we are using this particular loss function minimum R into AT, comma clip R comma 1 minus E plus 1 plus E into AT. So we are trying to take the minimum of the two entities, R into AT or the clipped version of R into AT. So why PPO is used? Because in case of advantage actor to critique, it is believed that as we are not making any upper and lower bounds, it can be the case that the training can become a bit unstable because of large updates happening into the model. So we need to clip the updates. We need to clip the updates so that the convergence is smooth, proving the stability while training. We're trying to clip the update amount that can happen into the model weights. So in case of advantage actor to critique, this can be big this can be big term, and hence updates can be very big. So it can be the case that the weights might be oscillating at a very high amplitude. But in case of PPO loss, as you're clipping R, so as you can see that when you're clipping R, we are trying to make it in the range of 1 minus E or 1 plus E. It can't cross these ranges, where E is 0.2 according to the paper, and R equals to probability of taking an action A in state S with current network upon policy of taking an action A in state S with the last network. Policy basically is the network that I'm talking about. Current policy network is the actor model. You would get it. Right. So, what do you mean by last policy and current policy? Last policy means that before the updates, before updating the weights, what was the network? We need to take consider that probability and the current probability that we are getting from the updated network. That forms our R. AT remains the same. Reward plus gamma, value function future state minus value function current state, and E is basically a constant that has been set up as 0.2 in the model. So with this particular loss function, the training is more smoother. So using this PPO methodology, eventually we will be training the SFT model and eventually getting a chat GPT. So let's understand the final training loop that we have. So first of all, we will be creating a copy for the SFT model. We will call that as a PPO model. Right, PPO basically stands for proximal policy optimization. So, in the advantage actor to critique method, this PPO would be taken as a policy network. It would be considered as an actor. So, which would be generating actions that would be Chat GPT's response. So, this whole has been converted into reinforcement learning environment now. So, we would be talking in terms of action, environment, agent. So, Now the action in this environment becomes ChatGPT's response given the context. So context is basically conversation history plus the new prompt. New prompt basically is the query that you are asking currently. Now create a copy for the reward model as well, and initialize the value network of actor critique method using this reward model. The PBO model generates a response considering the context plus prompt, right? Now this response is fed to the reward model to get a reward. Basically, if you remember, the reward model used to give us some score depicting the goodness of the response. Now we have got the response. We have got the reward. We have using the value network, we can get a value q values as well for a given action, and eventually we can calculate a loss function now. So the loss function, as mentioned, would be this r into 80 clip r comma 1 minus c 1 plus c into 80. Now one more term will get added to this, so that is called as a KL divergence term. So KL divergence term is nothing but, I will tell you what does a KL divergence term mean, how it is getting added, and what does it mean, why it is getting added as well. Now the loss function, that is final loss function that we get, is PPO loss plus KL loss. Now, using this loss function, we are updating both the models, that is the value network, that which is a copy of reward model, and the PPO model, that is a copy of SFT model. And eventually, this trained PPO model becomes a chat GPT. Now, what is scale divergence? So, scale divergence is nothing but it helps us to compare two different probability distributions, giving an idea on how far any two probability distributions are. So basically, it helps us in understanding the difference between two probability distribution. How it is calculated, the mathematics is quite simple. It is the negative summation of probability I log pi upon qi. So pi basically means that probability of the ith element coming from distribution A or distribution P, and Q is the probability of the ith element coming from the second distribution, that is distribution Q. Now in the training of ChatGPT, we'll consider P equals to PPO model, Q equals to SFT model. So try to understand how KL divergence term is calculated. So assume that ChatGPT generates a response with 10 tokens, right? So for each of the token, KL divergence term would become, we will be calculating the probability for each token coming from the PPO model, and then upon the QI becomes the probability for each token coming from the SFT model. Right. So what we would be doing is that we would be calculating the probability for each of the token that is generated from both the models, SFT as well as PPO. So do remember that as a PPO model was a copy of a SFT model, but so we are maintaining two copies of SFT. One is the original SFT that we would be using to calculate the KL loss term as well, and other is a PPO model that we are training. Actually, we are not training this SFT model. We are keeping it constant. We are training the PPO model, which is the copy of SFT model. Right now, in this way, KL divergence term is also calculated. So the loss term consists of PPO loss as well as the KL loss. Now, why we are adding this term? In order to avoid over optimization. So it is very similar to overfitting, where overfitting happens on training data set, over optimization happens on validation data set. So just recapitulating the whole diagram once, we take a pre-trained GPT-3 model, then using human generated conversations, we're doing a supervised fine tuning, getting us a super fine tuned SFT model now. Now using prompts plus historic context, we're feeding this SFT model and we're generating multiple responses, and then human ranks these responses to get us to a reward model, right? Now this reward model is basically used in the reinforcement learning environment, where PPO model, which is the SFT copy, this model, and value network, which is the copy of reward model. The PPO model generates a response for a prompt given the context as well. This response is fed to reward model to get a reward, and eventually using PPO model, value network, reward model, and SFT, we are trying to calculate PPO loss plus KL loss, and then using back propagation, we are updating value network and PPO model. Eventually, this PPO model becomes our chat GPT.